Have you ever wondered how we know how far away the stars are? Not guessed, not imagined, measured. Today, rockets travel beyond our planet. Telescopes peer into galaxies billions of light years away. AI analyzes cosmic data faster than any human ever could. But none of this would exist without one quiet discovery, made more than a century ago, by a woman most people have never heard of. Her name was Henrietta Swan Leavitt. She did not build rockets. She did not travel to space. She never became famous during her lifetime. Yet she gave humanity something far more powerful. She gave us a ruler for the universe. Henrietta Leavitt was born in 1868 in Massachusetts, United States. As a young woman, she loved learning and studying the world around her. But life placed an obstacle in her path. After a serious illness, she gradually lost her hearing. In an era with limited medical support, this could have ended her career. Many doors quietly closed, but one door remained open: astronomy. She joined the Harvard College Observatory as part of a group known as the Harvard Computers. Despite the name, they were not machines. They were women. Their job was simple, but incredibly demanding. They examined photographic plates of the night sky and recorded data by hand. No telescopes, no computers, no AI, just patience, discipline, and thousands of tiny dots of light. Day after day, Henrietta studied stars. She measured their brightness. She recorded their positions. She compared images taken months apart. To many people, this work looked repetitive, almost mechanical. But Henrietta noticed something no one else had seen. She focused on a special type of star, called a Cepheid variable. These stars change brightness in a predictable rhythm: brighter, dimmer, brighter again, like a heartbeat. In the darkness of space, most astronomers recorded the numbers and moved on. Henrietta did something different. She looked for patterns, and then she found one. The longer a Cepheid star took to brighten and dim, the brighter the star truly was. A simple relationship, a quiet law. But this discovery changed everything. Today we call it the Leavitt law, or in astronomy, the period luminosity relation. It allowed scientists to compare how bright a star appears with how bright it truly is. And from that difference, they could calculate distance. For the first time in human history, we had a reliable way to measure the universe. Astronomers later gave these stars a special nickname: the standard candle, a light whose true brightness is known, a cosmic lighthouse, guiding us through the darkness. Henrietta did not celebrate. She did not hold a press conference. She did not write headlines. She simply continued working, quietly, carefully, faithfully. Years later, another astronomer named Edwin Hubble used Henrietta's discovery. With her method, he measured the distance to distant galaxies, and then he realized something astonishing. The universe was expanding, not static, not fixed, growing, stretching, moving outward in every direction. This idea transformed science forever. It became the foundation of modern cosmology, and it all began with Henrietta's data. But history can be unfair. Edwin Hubble became famous. His name appeared in textbooks. Space telescopes were named after him. Henrietta Leavitt remained in the shadows. She passed away in 1921, at the age of 53. Just a few years later, scientists considered nominating her for the Nobel Prize. But there was one problem. The Nobel Prize is not awarded posthumously. Her chance had already slipped away. Today the world is entering a new era of discovery. Artificial intelligence analyzes massive datasets. Space agencies plan missions to Mars and beyond. Private companies launch rockets almost every week. The universe feels closer than ever. Yet the foundation of this progress still rests on a quiet insight from a quiet woman working in a quiet room. Henrietta Leavitt was not loud. She was not celebrated. She did not seek attention. But she changed how humanity sees the cosmos. She proved something powerful. Great discoveries do not always begin with explosions. Sometimes they begin with patience, with observation, with persistence, with the courage to keep working, even when no one is watching. In many ways, Henrietta was the first data scientist of the universe. She worked with massive datasets. She searched for patterns. She transformed numbers into knowledge. Long before computers existed, she practiced the art of data analysis. Long before AI, she showed us how insight is born, not from noise, but from attention. Today, when scientists measure the distance to distant galaxies, when engineers guide spacecraft across the solar system, when astronomers map the edge of the observable universe, they still rely on the principle Henrietta discovered: a rhythm of light, becoming a ruler of space, a simple pattern, unlocking infinite distance, a silent architect, designing the structure of modern astronomy. So the next time you look up at the night sky, remember this: behind every galaxy measured and every mission launched stands the work of someone you may never meet, someone who stayed focused, someone who stayed patient, someone who believed that careful work could change the world. Henrietta Swan Leavitt did not travel to the stars, but she showed humanity how to reach them. Because sometimes the person who changes the universe is not the one holding the telescope. It is the one quietly measuring the light. If this story inspired you, subscribe to Hope Reactor, because history is full of hidden legends whose quiet courage still shapes our future.